All right, so today we are solving trig equations. Today it's going to be by isolation and factoring, which mainly just means straight up algebraic stuff that we've done, that you've been doing for years and years. And here's what I want you to remember about that, is that you started learning algebra way before you ever took a class called algebra. Like you learned how to solve equations, and whatever you do to one side, you do to the other, and combine like terms and all that stuff. Those steps never change. Okay, and those are the same steps that you need to be rock stars at now in calculus and your future maths, and those are the same steps that usually slow you down and mess things up if you can't do them right. So remember that the steps are the same. Even when things start to look different because they've got trig in them and they've got square roots, it doesn't matter. It's still the exact same algebraic stuff you've been doing. Okay, so don't try and make it harder just because it's trig. All right, so let's start by, it says graph the function of f of x equals sine x below. All right, so I know that at 0, sine is 0. I know at pi, sine is 0. And I know at 2 pi, sine is 0. I know at pi halves, sine is 1. And I know at 3 pi halves, sine is negative 1. And that's good enough for me to be able to sketch in this. Ooh, that one looks pretty good. Maybe I should take Bitter's more. All right. So maybe that's the key to my good pictures. I don't know. All right, so it says over here, give the solutions to the equation sine of x equals 1/2 on the interval from 0 to 2 pi. All right, so when we're solving these, they're going to be giving us intervals. In this case, it's from 0 to 2 pi. So it's the part of the graph that I have that doesn't have the arrows on it, because the graph actually continues, but it would be just obviously starting here and stopping here. So we can do this two ways. It's not asking me for an x value. I'm sorry, it's not asking me for a y value. It's actually asking me for the x value. So it says if sine of x equals 1/2. So if the sine value is 1/2, here's when the sine value is 1/2. It happens here on the graph and here on the graph. That is not something that I can just guess off the graph. But you can think about it as if I wanted to actually solve this, then that would mean x is equal to the sine inverse of 1/2. Now, if we were going to straight up just do the inverse like we did a couple weeks ago, that means you have exactly one answer, and you only get your sine answers from quadrants 1 and 4, right? And this is positive, so it's coming from quadrant 1. So when is sine 1/2? Pi 6, okay? So that means it happens at pi 6. But so if I was to answer this right here, I would say, okay, x equals pi 6. These questions are asked a little bit differently. It's not asking me what is the inverse of 1/2. It's saying solve this, and it's giving me an interval. So I need to know on that interval every single time it equals 1/2. And I can see from the graph, not that we're going to graph it every time, but I can see from the graph I'm supposed to have two answers, right? So I know one of them, this would be my pi 6 answer, right? This would be pi 6. And then the other time it happens, if we don't have a graph, then we think, okay, for sine, I know sine's positive in the first quadrant. What other quadrant is it positive in? The second quadrant. So I need my second quadrant pi 6 answer, or my second quadrant pi 6 angle. What's that? 5 pi 6. So it says give the solutions, that's plural, so that's a hint that it's probably more than one. That's when you get sine of x equals 1/2, anywhere from 0 to 2 pi. Everybody okay with that? So the graph continues in both directions, right? Just keeps repeating for infinity in both directions. So now it says give the solutions to the equation, same equation, but this time what changes is the interval. Now we're going from negative infinity to infinity, which means there's going to be an infinite amount of answers, so obviously we're not writing them all down. We're going to write them in the same kind of manner we did for when we were having to write our zeros and our asymptotes and stuff. I'm going to let you leave off n as an element of the integers just because I know that's a lot of stuff. So x equals, so we know it's these two answers, so I know pi 6 is one of them. So then I got to think, okay, it's pi 6. So when this graph starts to repeat itself, it's going to happen again right here. What's the distance between pi 6 and whatever this angle is here? 2 pi. So, and then it's going to happen again, and there'll be another 2 pi, and it's going to happen again and again. Make sense? So we're going to say plus 2 pi n. And we just know n is an element of the integers. So even though it's just plus, it's also minus because n could be a negative number, and it's going to hit all of them. But that doesn't include this one, because when I add 2 pi, I don't get here. So I also have to have my 5 pi 6 plus, and then the same thing, because the period is 2 pi, it's going to be 2 pi away, so it's 2 pi n. And those are my answers. The majority of the time when you are solving trig equations, you are interested in a specific interval. Okay, so that's how most of them are going to be done that we do. But I did put a couple of these in here because you still need to know how to think about that as well. If this was tangent and not sine or cosine, then it would be pi and not 2 pi because it goes with the period for the function. Does that make sense? And then it works the same for secant and cosecant, all those. Okay. All right, so let's look at what we're doing here. It says a trigonometric equation can have one solution, no solution, or several solutions, or an infinite amount of solutions, really. And it depends on the defined interval, so we have to pay attention to those. To solve a trigonometric equation, so we want to solve. Okay, thank you. This is it. Thursday, 5th period. I was right. Okay, to solve a trigonometric equation, we isolate the trigonometric functions. What that means is you solve these just like you solve a regular equation. If we have a simple algebraic equation and you're solving for x, your goal is to isolate the variable, right? That's our goal here too, but we isolate the trigonometric function. That's like isolating the variable. So like instead of x, we have cosine x, and that's what we isolate. Then from there, the only difference between what we've done algebraically and what we've done algebraically before, then at that point, I have to actually take the inverse and think about the trig stuff. Does that make sense? Or a lot of times what we do, the trig stuff and the pre-cal stuff comes first, and then we finish with algebra. Here we kind of start with algebra and finish with the trig stuff. Basically, that's that simple. All right, so let's look at number 1. It says it says to solve for the values of x on the given interval. So my interval is from negative infinity to infinity here. So I need to think around the entire circle, and then I can just, so I could have 4 answers because I could get 1 from each quadrant or whatever, but I need to think around the circle, and then I'm going to just go from negative infinity to infinity. All right, so I want to solve this. I'm trying to isolate my variable. So I would want to combine all my cosine x's. So I think I'm going to want to subtract this over here. And then I'm also going to need to move this, so I'm going to move this over here. So I'm going to do more than one thing at a time, which is fine because this isn't a proof. So when I subtract 3 cosine x from both sides, I get 2 cosine x. That's going to equal, when I subtract the square root of 2, I get negative square root of 2. So then cosine x equals negative square root of 2 over 2. Everybody with me so far? So let me just think through my reference angles. If it's square root of 2 over 2 for cosine, that means it's a pi 4th angle. In what quadrants is cosine negative? 2 and 3, 2 and 3. So that's where I need to get my answers from. So that means that x is equal to, and then my pi 4th angle in the second quadrant is what? Pi 4th angle in the second, 3 pi 4ths. So 3 pi 4ths. But because I'm going from negative infinity to infinity, it's going to happen every 2 pi like that, right, as I go around the circle. So I'm going to put plus 2 pi n. Then I also need my third quadrant, pi 4ths angle, which is 5 pi 4ths, yes. Then that's plus 2 pi n as well. And those are my answers. Any questions at this point? All right, so we're going to look at, again, we're going to have to think about the whole circle here. My variables is basically secant y. That's what I'm treating as my variables. So I'm going to subtract secant y from both sides, so I get 6 secant y equals negative 4 square root of 3. Then to get secant y by itself, I'm going to divide, so I get secant y equals negative 4 square root of 3 over 6. Can I reduce that fraction on the right-hand side? Yes, I can. So I get secant y equals negative 2 square root of 3 over 3. Okay, so some of you may know your secants and cosecants just like, quickly, but I think through them through cosine and sine and tangent because that's just what makes the most sense to me. So in my mind, or actually probably what I'd write down as well, I would change this to cosine y. So then that's going to give me, what's the reciprocal of 2 square root of 3 over 3? Yes, square root of 3 over 2. Y'all used to know those a lot quicker. So here's my hint for you right now. Because it's been a while, all right? I don't feel like all of you have completely forgotten everything about the unit circle, but you need to, kind of refresh your memory on it sometimes. But probably the thing that was the least solid in your brain when we stopped doing them every day was the reciprocals that matched. So in the Quizlet flashcards, there's a set of flashcards, just in case you've never seen them or used them, that has no trig in it or anything. It's just literally the reciprocals you need to know. So the flashcard would give you this, and you've got to come up with this and vice versa. And if you just go through those a couple times, because those are only a few numbers, and when you have those tied together, it just saves you some time so you don't actually have to take the reciprocal and solve. You'll know them. If you just do it a few times, you'll just kind of, knock the cobwebs off. All right, so cosine of y is negative square root of 3 over 2. So my y values then, so cosine, when it's square root of 3 over 2, and y'all know what I mean when I'm doing this, right? I'm not making up sad math gang signs or anything. So my cosine is the square root of 3 over 2. My angle is pi 6. But cosine is negative in which quadrants? 2 and 3, because I happen to do a cosine again. So my second quadrant pi 6th angle is what? 5 pi 6. It would be plus 2 pi n. And then my third quadrant is 7 pi 6 plus 2 pi n. And remember that, so if I'm thinking in 6, this is 6 pi 6. I back up 1 to get to 5. I go forward 1 to get to 7. And there are my answers. Okay. What questions do we have? Anything? All right. So when we get to the other ones, where they're not from negative infinity to infinity, I'm still going to draw myself a little picture, but of where this is. So from pi to 3 pi halves, I'm in the third quadrant. So that's the only part I'm interested in. I don't have to worry about the rest. So I'm going to solve this. Let's see, I'll move my tangent A to the left, so that'll give me 2 tangent A equals negative 2. So tangent A equals negative 1. Okay, so if it's 1, it's a pi 4th angle. Tangent is negative in which quadrants? 2 and 4. So here's where tangent's negative. The only place I want an answer is in quadrant 3. Do I get an answer from quadrant 3? No. So my answer then is the empty set. There's nothing to put in there. Even though this is solvable, it's like my answer isn't undefined. I can solve that and I can give you tons of answers, but not in the interval you want. So I don't have a solution in that interval. We okay with that? Alrighty, so let's look at number 4. So I'm going from pi to 3 pi halves again, so it's the same interval. So now I have 4 sine squared u plus 8 equals 11. Now remember, this is a simple algebraic thing. Don't go start making up math and doing weird things because it has sine in it. Would I start, excuse me, should I start off by doing anything with the 4? No. What's the first thing I move? To subtract 8. See, it's the same. Y'all know exactly what to do with all this stuff. So 4 sine squared u equals 3. So sine squared u equals 3/4. I don't care about sine squared. I really don't even care about sine because I want u. But to get there, I'm going to have to take the square root of both sides. So that leaves me with sine u equals plus or minus. Do not forget the plus or minus. Then that would be the square root of 3 over 2. No, because I'm taking the square root. But thank you. So when I take, because I kind of skipped that step, I take the square root of 3/4. So it's the square root of 3, and then I can take the square root of 4. So you got to make sure then that you don't drop that square root down where it looks like the 2 is inside of it. All right, so now that I have that, Well, when sine is square root of 3 over 2, my reference angle is pi thirds. And since that's plus or minus, that means I could get an answer actually from each quadrant, but I only care about the answer from the third quadrant. And in the third quadrant, is it positive or negative? Negative. And the third quadrant pi thirds angle is what? 4 pi thirds. And I'm done. Oh, and this should still be a set, even though there's one. What questions do you have? Anything at all? So these were all basically just isolating the variables, solving simple equations. Now we're going to get into some factoring. And you have to know how to factor. And if you can't factor with just x's, factoring with trig is going to make it a bazillion times harder. If you can factor with x's, you can factor with this stuff just fine, because it's literally the exact same stuff. Huh? Why is it? Oh, it is not negative 4 pi thirds. Thank you. I think, yeah. Oh, I don't know why I did that. I think I did that instead of my brackets, and that's why I felt like, oh, I forgot my brackets, and I put a negative there. It is, but the angle is positive. Like the sine, you're right. The sine is negative, so this, my sine value would be a negative square root of 3 over 2, but in this quadrant, the angle itself is a positive 4 pi thirds. I've confused you by putting the negative. So when I think about the angles, like forget the values, the positive, negative values, right? We're going to go around the unit circle with my pi thirds angles. So I got pi thirds, this is 2 pi thirds, this is 4 pi thirds, this is 5 pi thirds. Those are the angles, right? When I take the sine of 4 pi thirds, it gives me a negative square root of 3 over 2, but the angle is positive. Make sense? And I'm sorry, I confused you by putting that, so we're good? All right. So let's look at number 5. So now we're going to factor. There's a different way to do number 5. We could do number 5 kind of like we just did the other one, but I'm going to force you through factoring on some of these because I want to make sure you see this, because sometimes you need to factor things. This is already set equal to 0. I'm going from 0 to 2 pi, so that's the whole circle. So I could have up to 4 answers. Well, actually, I could have more than that, and I'll tell you why in just a second. But can I factor the left-hand side? Yes, because what is that setup called? Difference of squares. And that's why I'm forcing you down that road, because I want you to see it. So we're going to make this 2 cosine x plus 1 times 2 cosine x minus 1 equals 0. Now I'm going to do more steps on number 5 than I am on the rest of them, because I want to make sure that you're following me on what is pure algebra and so forth. So I've got this completely factored. Just like you would do if this was just x plus 1, x minus 1, or whatever it is after you factor, you take each factor and you set them equal to 0, right? Your zero sum thing. So we're going to make like a little T-chart almost thing, just so that you can keep your work organized and I can follow your work. And so we're going to take each one of these. This is 2 cosine x plus 1 equals 0, and 2 cosine x minus 1 equals 0. Then we're going to solve each one of them separately. So this gives me 2 cosine x equals negative 1. So cosine x equals negative 1/2. So x, using the whole unit circle, cosine is negative in quadrants 2 and 3. When cosine is 1/2, it's a pi thirds angle. So what's my second quadrant pi thirds angle? 2 pi thirds. And my third quadrant? 4 pi thirds. Okay, so I've gotten that one taken care of. Now I got to go do this one. So this is 2 cosine x equals 1. So cosine x equals 1/2. Cosine is positive in quadrants 1 and 4. It's still a pi thirds angle, so I get pi thirds and 5 pi thirds. Then once you do each one of them, because you might have 3 or even 4 that you have to work through, then you go and you look at all these answers and you got to put them together, and they have to be in order. It's all one answer. So this would give me pi thirds, then 2 pi thirds, then 4 pi thirds, then 5 pi thirds. and that's my answer set between 0 and 2 pi. We good? All right. So let's look at number 6. On number 6, we are only interested in our answers from pi to 2 pi. I'm going to draw that in there so I can use it at the end to make sure I'm using the right answers. I'm going to need to factor, so I'm going to need to set it equal to 0. We can move everything to the left or everything to the right. It really doesn't matter. What would you choose? To the left? Okay. That's what I would choose, but again, because that's what was drilled in my brain, but last period somebody said, right, it really doesn't matter. So cotangent x minus cotangent x times sine squared x equals 0. Are the cotangent x going to cancel out? No, because that doesn't make any sense, right? Because that's not how we combine like terms. Is there something I can factor out? I can factor out a GCF. So I'm going to factor out my cotangent x. That leaves me with 1 minus sine squared x equals 0. What kind of setup is that 1 minus sine squared? It is a Pythagorean identity, and we actually could use that. We're going to wait till tomorrow to do identities, but I actually could do that. We're just not today, so that's good. How can I factor? What's it set up like? Difference of squares. All right, so I got cotangent x, so that's very good that you recognize that, times 1 plus sine x times 1 minus sine x. So it's still difference of squares even when the variable is in first. And again, we wouldn't necessarily have had to factor that. I'll explain that in another one, but I'm going to make you do that on a couple of these. So then I'm going to split these up. Okay. And cotangent x equals 0. I'm more comfortable thinking through tangent than cotangent. So I'm going to make that into tangent. And when I make that into tangent x, I have to take the reciprocal of 0, which is undefined. And I didn't leave myself enough room, but good enough there. So then I ask myself, ask me a question because you're looking at me like I'm crazy. Undefined. Undefined, yeah. A reciprocal of 0 is undefined, and that's, yeah, I just kind of crammed it in there. As long as you can know that that's what it is, we're good. Do you understand why I did it, though? You just couldn't read me. Okay, that's fine. Okay. So when is tangent, oh, and I need to look up here. I only care about from pi to 2 pi. So when is tangent undefined? At what angles? 3 pi halves. It's pi halves and 3 pi halves, but I don't care about pi halves, right? So it's 3 pi halves. So I'm done with that one. So on here, I'm going to skip this step and the rest of them, because hopefully you know you're setting them equal to 0 and you can kind of shorten it down a little bit. So that means here I would get sine x equals -1. And so between pi and 2 pi, when is sine -1? 3 pi halves. Okay. Between 1, oh no, I'm sorry, let me do this. So sine x equals 1. So between pi and 2 pi, when is sine 1? At pi halves, and is that included in here? No, so I don't have anything. Nothing's helpful there. I mean, you could write down pi halves, but we're going to end up not using it, because all I care about is what's between pi and 2 pi. These two happen to be the same number. That's a coincidence. It's just the nature of the problem. That's not going to happen every time. So even though I have 2 answers, I really just have 1 answer. And my answer is x equals 3 pi halves. It's the only solution to the equation in there. So we're not saying that sine x never equals 1. It just doesn't equal 1 in the interval I'm interested in. Everybody good so far? Okie dokie. Let's look at number 7. Okay, so number 7, I've got a squared in it. That means, hey, it's a quadratic, and the majority of the time when you're solving quadratics, you set it equal to 0. Really, the only time you don't is if you're going to use the square root method or if you're completing the square. But we're going to set that equal to 0. Let me draw my little picture here. I've got from 3 pi halves to 2 pi, so this is the only part I'm interested in. I'm going to set this equal to 0. So I get cosecant squared theta. I'm going to add that cosecant to the left, plus cosecant theta. I've got 5. I'm going to subtract 7, so that's minus 2. That equals 0. So this is not a difference of squares, but I need to be able to factor it. So when I factor it, the first term is cosecant theta for both of them. This is negative, so the signs are opposite. The fact that I have to multiply to give you 2 seriously reduces the number of options you have. It's 1 and 2. Which one's positive, the 1 or the 2? The 2, because this is positive right here. So this is what we have. So that means what I have here is cosecant theta equals negative 2. But I want to change cosecant to sine. So sine theta is negative 1/2. So is sine negative in the fourth quadrant? Yes. Okay, that means we're gonna get an answer. We're only gonna get one because I'm gonna get whatever angle works here. When sine is 1/2, that's pi 6. So what is my fourth quadrant pi 6 angle? 11 pi 6. All right, so then I have cosecant theta equals 1, which means sine theta equals 1, because that's the reciprocal, right? When does sine theta equal 1 between 3 pi halves and 2 pi? It doesn't. So there's just nothing there. I mean, if you want to write it down because you feel like you need to put something or you're confused, that's fine. We just don't use it in the final answer. I only have one answer, and that is 11 pi 6. What questions do you have? Alrighty. So let's look at number 8. I'm going from 0 to pi, so I'm going to go ahead and put that on there. And let's see. I'm going to have to factor, I think I want to move everything to the left because I just have one thing to move there. And so this is going to give me sine x secant x plus, so I have 2 square roots of 2 sine x. Here is just square root of 2 sine x. So when I subtract it over there, I'm left with square root of 2 sine x equals 0. Not a quadratic, right? But do I have a GCF? And that should be the first thing I look for, whether I have a quadratic or not. Yes, I have a GCF. My GCF is sine x. So sine x times secant x plus the square root of 2 equals 0. So I have factored it as much as I can. Now I'm going to solve it. So here I have sine x equals 0. So when does sine equal 0 between 0 and pi? Pi and 0. Happens to be a 0 and pi. Okay. Here I would get secant x equals negative square root of 2. I would like to make that into cosine. So cosine x equals, oh, that is not a cosine x. See, my brain and my hand do not always agree. Oh, and then my board freezes up. Freezes up when I mess up, so everybody can look at it long. There we go. Cosine x equals, then what's the reciprocal of negative square root of 2? Square root of 2 over 2. Good. All right. So if it's a square root of 2 over 2 for cosine, that's a pi 4th angle. But this is negative. Is cosine is negative in which one of these quadrants? Either one of them? 2. So it's only in the second quadrant is when cosine's negative. So what's my second quadrant pi 4th angle? 3 pi 4ths. Good. So then I put them all together and I put them in order. X equals 0, 3 pi 4ths, and pi. Pay attention to your intervals because they could be written in inequality notation as well. But you could see something like instead of this, it could look like this. And if it looks like that, would I include this pi? If it looked like this, I wouldn't then, right? So, and that's not what it says. So we did it right. I'm just saying pay attention to that if that happens to come up. All right, any questions at this point? Alrighty. Number 9. I'm going from pi to 2 pi. And I'm going to move everything to the left. So I get secant to the 4th x minus 5 secant squared x plus 4 equals 0. So this is a quartic, but it's set up like a quadratic, so I'm pretty confident I can factor it and just kind of treat it like a quadratic. So I'm going to have 2 terms here. This is going to be secant squared x at the beginning of both of them. Since this is positive, these 2 signs have to be the same. And since this is negative, they both have to be negative. So I need 2 numbers that multiply to give me 4 and add to give me 5. What are they? 4 and 1. Okay, so now when we look at this, could we factor it more? Yes, because I have another, both of these are difference of squares, right? And just because it's a difference of squares doesn't mean you have to factor it. I mean, I made you do it on the other ones because I want you have to at least be able to recognize it and know that you could, because sometimes you need to, sometimes it helps to cancel things out or whatever. It also helps you not to miss things, and so we'll talk about what those are in just a minute. So I could factor this out and have 4 terms, but instead we're just going to go ahead and solve them from here because that's fine too. So that means this would give me secant squared x equals 4. So secant x equals plus or minus 2. That's what you can't forget, and that's what a lot of people forget when they do it this way. Where when you factor it into difference of squares, it forces you to have 2 of them. Don't forget your plus or minus. I'm going to change this to cosine, and I'm going to make that plus or minus 1/2. So cosine is negative here and positive here. So when cosine is 1/2, that's a pi thirds angle. So I need my pi thirds angle from quadrants 3 and 4. What's my third quadrant one? 4 pi thirds, and then 5 pi thirds. So then here I get secant squared x equals 1. So secant x equals plus or minus 1. Make secant into cosine. The reciprocal of 1 is 1, so it's still plus or minus 1. Then between pi and 2 pi, when do I get a positive or negative 1 for cosine? At pi and 2 pi. And then remember, when you write them down, they need to be in order. So I would start with pi, then do 4 pi thirds, then do 5 pi thirds, then do 2 pi. And that's what I end up with. What questions do you have? All right, let's look at number 10. I'm going from 0 to pi, right there. It's already set equal to 0, and I feel like it's something I'm going to have to factor. It's a cubic. I got 4 terms. What do I do? Grouping, exactly. Anytime you have 4 terms, usually grouping is the way we want to go. So we're going to do grouping. So from these first 2, I can factor out a tangent squared. So tangent squared times tangent plus, oh, sorry, not just tangent. Oh my goodness, I'm leaving off my y's. Let me rewrite this. Okay, tangent squared y times tangent y plus 1. Out of these 2, I'm going to factor out a negative 3, so that leaves me with tangent y plus 1 again, and all that equals 0. So tangent squared y minus 3 times tangent y plus 1 equals 0. So I've factored them. That first term is actually not a difference of squares. You could kind of force it down that road, but I wouldn't want to factor it anyway, so separate these. And that's going to give me tangent squared y equals 3. So tangent y equals plus or minus the square root of 3. When tangent is the square root of 3, my reference angle, like what if I just have square root of 3, when is tangent square root of 3? Pi thirds. So it's a pi thirds angle. I know that tangent is positive in the first quadrant and is negative in the second quadrant, so I'm going to need both of those. So that means that y equals pi thirds and 2 pi thirds. Then I get tangent y equals negative 1. Tangent, when tangent's 1, that's pi fourths, right? But I don't care about positive 1. I only care about negative 1, which would be the second quadrant. So what's my second quadrant pi fourths angle? 3 pi fourths. Then when I put them together, I need to put them in order. Clearly pi thirds comes first. But then what comes next? 2 pi thirds or 3 pi fourths? 2 pi thirds and then 3 pi fourths. And that's just your understanding around the circle, not necessarily fraction values there. Okay. What questions do you have? You see how it's just a combination of the algebra you've known forever and then the trig we've just learned? But you just got to put it together and make sure you're thinking about the right values and you're good. Okay? Any questions at all? Alrighty.